to our video about how to solder, specifically how to solder components for the Underwater Remotely Operated Vehicle program. We are going to demonstrate the process and then also show you how to solder to a motor in this video. First, we want to talk about the soldering iron. For this project and these Weller soldering irons, the temperature shouldn't be much above 4 on this scale. That is about 600 degrees Fahrenheit, which is hotter than your oven will get. You don't want to go much above 4. That works just fine for this project. As we're dealing with a soldering iron, you want to hold this like a pencil. If you're right-handed, hold it in your right hand. Left-handed, hold it in your left hand. This part of the iron is very, very hot, 600 degrees Fahrenheit. You don't want to touch that. You also want to make sure that your hair, any kind of loose clothing, and your jacket straps are out of the way so that you don't accidentally burn them. Also, you want to make sure when you're soldering, you're very careful about your surroundings. Don't talk with your hands. If you're talking, put your iron back in its holder, talk, and then use your iron when you're ready to solder. You want to make sure that people around you are safe as well as you're safe. This iron is specifically used to heat your workpiece so that you're able to solder. We don't want to damage tables, have you get burnt, or damage any other equipment because of the heat. So it's only used to solder the pieces that you're working on.
So let's talk about the solder itself. The solder, normal solder that is used in industry is a lead-based solder. But lead is a neurotoxin, and it's really not very good for people. So the solder that we bring out to the schools for you is a lead-free solder. This solder is mostly tin, a little bit of copper, and just a tiny little bit of silver. So it's not as toxic, but it works very, very closely to the same way that leaded solder would work. We also use, while we're soldering, a thing called flux. Flux is a petroleum-based heat-activated mild acid. It's used to make the surface that you are soldering to clean. It flows away any oxides and grease and oil and those kinds of things. So I told you it was a mild acid, so it's kind of like lemon juice. It's not going to hurt your skin, no big deal. If you touch it, be sure to wash your hands after you use it. And then we have general safety. Soldering is a process that requires you to wear safety glasses. So we have regular safety glasses and safety glasses that fit over your prescription eyewear. Always, always, always wear your safety glasses when you're soldering. And then we have a variety of tools here that have a variety of safety issues. You have things that might cut you, things that might pinch, and always remember to use the right tool for the job that you're working. That's important, and it'll help you out a lot. Always be aware of yourself and the people that are around you when you're working with these tools.
Okay, back to the soldering iron. I'm going to show you how to keep your soldering iron in good condition so that when you try to use it, it works well for you. If it is not in good condition, it will not work very well, and that causes problems later on down the road. So this here is a good condition soldering iron. And when I say good, if I wipe this a little bit, you see that the tip is very shiny, okay? In contrast, this tip, you see that it's brown, it looks kind of rusty. It has sat too long in the wrong condition and oxidized, which also prevents it from working very well with your project. So you'll notice I just put some solder on the iron. Process for when I'm using this iron. I'm getting ready to solder something. I pick it up out of its holder. This cleaner takes a little bit of the solder off. You don't have to jam it in there. It's just a little wipe back and forth, both sides of the tip. I dip my solder in flux, have just a tiny bit of solder on that, or tiny bit of flux on the solder. You don't need big goops of it. And then I'm putting solder on the tip. The solder on the tip of the iron helps that tip so that it doesn't oxidize like the other tip that you saw. It also helps keep the tip in good condition so that when you solder, the solder will flow onto your component nicely. If your tip starts to look like this or like this, where it's oxidized, when I try to add solder to it, it does not adhere and it just makes a ball of solder. Okay, that's a problem, and it makes it so that you're soldering, when you're soldering to a component, very difficult, if not impossible. So I can't stress how much keeping this iron clean means. So if I were to be soldering to a component, again, I would put solder and flux on my iron. I would solder my component, do whatever I was going to do. And then right before I get ready to put it back in its holder, again, I clean it off with this cleaner, dip my solder in the flux, put a puddle of solder back on the iron, both sides, so it's well covered, and then I'm going to put it back in its holder. If I'm done for even just a little while, say 10-15 minutes, I'm going to turn it off. Okay, there's an on-off button. I'm going to turn it off. If the iron just sits, it has more probability to oxidize and cause problems in the future for your soldering. So we want to make sure that when we're not using it, it's turned off and not having that oxidation process. Please make sure that you put solder on the tip all the time. You're going to feel like it's excessive, but that's okay. It prevents any kind of damage to the tip, and it will help your soldering as you go along.
So let's talk about the actual soldering process itself. So soldering is a chemical bond. That means that you're taking solder molecules and you're actually combining them with the copper atoms. So you're making a new alloy, which is not like a hot glue process. That's a mechanical bond. With the hot glue, you wipe the hot glue on the cold surface and it sticks. And then you put the other thing on there and it sticks. But that's just a mechanical bond, and that'll tear very easily. When you're done soldering, if you solder two pieces of wire, it is a continuous metal from one end of that wire to the other end of that wire through the solder. There's no breaks in it whatsoever. So it makes a very reliable electrical connection. And that requires the heat energy from your soldering iron. It also requires that there be a certain amount of cleanliness. That's why the flux is there, Okay, there's some flux in the solder already, but as you've noticed, my partner dips her solder in the flux before she uses it. That adds just that tiny little bit of extra flux that's needed to make this solder work very nicely. So that bond that you're seeing is, you can't really see it happening. You're combining atoms and molecules. But there are some things that you can actually see that show you that you are indeed making a good chemical bond. The first thing is that it's the piece of work that is melting the solder. So the wire is going to melt the solder. The iron only is there to heat up the copper so that the copper will melt the solder. And if this copper is hot enough to melt the solder, then the solder is going to flow onto the copper. And we'll show you that up close and personal when we start demonstrating with the actual soldering process. But right now, just know it's the copper that's melting the solder, and the solder is flowing onto the copper. These two things that you can actually see are going to tell you that you're making a good solder connection. And it takes a great deal of heat. So think about heat transfer. If I have two things that are connected like this, there's not really a lot of surface for the heat to be transferred from one to the other. But if I connect them like this, I have lots of surface for that heat to be transferred. So that's why we talk about making a good mechanical bond before we make that solder bond. And it also limits the amount of solder that is required to make the good bond. So we're going to talk about a thing called a puddle of solder. So when I have my iron, and right now you can see my iron is dry, but I'm going to add some solder to it, and you see that the solder puddles. That puddle is going to be a solder bridge, or a bridge for the heat transfer that helps me make things hot quickly. So let's talk about the first thing is going to be tinning a wire. Before you can tin a wire, you're going to get a piece of Cat 5 that looks an awful lot like this, and you need to strip this blue jacket off of this Cat 5 cable. And there are a couple of ways to do that. We have a jacket stripper, which is hot, and you'll notice up here on this end, I have two different sizes of hole there for that jacket to fit into. So I'm going to use the larger one for this size. I'm going to put my jacket stripper on there, and it goes around once, twice, but not more than that. If I go too much more than that, I'm going to cut through the jacket, and I'm going to cut into the insulation on the wire underneath. And I don't want to have that happen. But you can see now I've got my insulation, my jacket is stripped, and I can take this off. If you're stripping a lot of jacket at once, I would highly recommend that you take it in several smaller pieces, not really small, but pretty small. I wouldn't strip this much, but I would strip that much twice. Or I can use cutters to start that jacket. Just get a little cut down the jacket, and I can work that cut open, get the wire coming out of there, get a hold of that wire and that jacket, and I can pull this wire down the jacket, strip as much as I would like, and then just very carefully, so as not to damage the wires, cut off that extra jacket. And then I have 4 wire pairs that are here that I will be using the wire pairs. Are you going to go next?
Your turn.
Okay, so then with the wire pairs, I'm going to untwist just a little bit of this wire, and I'm going to take these wire strippers, not the jacket strippers, the wire strippers, and you'll notice that there are a bunch of different sized holes on these wire strippers, and they're numbered. The smaller the number, the bigger the hole. Those numbers are correlate to American wire gauge, and this happens to be 24 gauge wire, so the second to the end, okay, I'm going to put my wire in there, and I want to make sure that when I pull this, I pull the wire straight out of the stripper, and you'll notice that it stripped that wire very nicely. I want to avoid pulling at an angle, right? I want to keep my stripper square to my wire when I strip the wire. And there, my wire is nice. Now I'm going to put solder on this wire with nothing else. This is a process called tinning. I'm going to tin this wire. The first thing I need to do is make sure that all of the strands, so there's a bunch of different strands here, I need to make sure that they are all together for a good mechanical bond. So I make a good mechanical bond with my strands of wire. I'm going to need to add a little bit of flux. So for this process, I can just dip my wire in the flux, or if you prefer, like my partner did, you can add flux to the solder. So now I've got flux on my wire, and I'm going to tin this. And we're going to need to look really closely at this and watch carefully, because this process happens very fast. Okay, I told you I would show you solder flowing onto the workpiece. Well, this is where that happens. So I'm going to start with a pretty good sized puddle. I need to have this puddle is not just for heat transfer. I'm also going to have this puddle to add solder to the wire. So when I put this puddle on the wire, it's going to flow onto that wire very quickly. And here we go. And then you notice I wipe away from the insulation. You also notice that the insulation shrank back away. And now I have some bare copper here that did not have flux on it. So I can, if I have too much of that, I want my tin to go all the way to the insulation. So I'm going to reheat my wire, and it's the copper that's melting the solder. And I can show you that process again over here. Same thing. I build a nice good sized puddle on my iron, and when I touch the puddle, that solder is going to flow onto the copper. And it flows on, I wipe away. I might have to come back and add a little bit more, but it's the solder that's being melted by the copper wire, not the soldering iron. And then again, clean, add solder, put your iron in the holder.
Okay, so now that we have our wires tinned, we're going to talk about adding the wires to the motor for the remotely operated vehicle. So the motor will be on one end of this Cat 5, the opposite end will have a switch. So before I get started with these wires, they're a little bit long, so I'm just going to trim them down. Okay. And then for attaching to this motor, we want to attach mechanically first and chemically second. So I like to make a hook in the wire, and that wire can either go over the terminal like this, around the terminal, or through the hole. I'm going to choose to go through the hole just because I feel like it helps mechanically hold it better. Okay, so nice and tight so I have a good mechanical connection. Then I'm going to use the helping hands so that my hands are free to hold the soldering iron, the solder, and anything else I may need. Okay, so mechanical connection there. Again, I'm going to use my solder. I like to dip it in the flux first, just get a little tiny bit on there. I'm going to clean my iron, get a nice puddle on the soldering iron for that heat transfer. And then my iron is going to go on one side of the terminal and the solder on the other side. Should be pretty fast. If it's not fast, your iron probably needs to be cleaned, or you don't have enough of a puddle of solder on the iron. When I give a little tug on this, you can tell it's on there tight, it's not coming off, it's nice and stiff, it doesn't move back and forth. Okay, you want to make sure you've got a good connection there so that when we hook this up to a battery, you have good electrical flow. If it's loose, your electrical flow will not be good and potentially will be intermittent. Okay, so that would be a good solder joint there. It's covering the terminal. This wire would ultimately go here. And with both of these, we have very little insulation removed from the wire. We don't want to strip clear back to here and have a lot of wire exposed, because then we have a potential for a short. You'll also notice that I didn't get close to the tape. We want to make sure that we don't melt the tape. Otherwise, we have other problems during our motor waterproofing process. At the end, this is what it should look like. You've got your cap on the motor, on the wires, and then you have both wires soldered on to these terminals for the motor. They're soldered for polarity. And not much insulation past where the solder joint is that has been removed. Okay, that finishes our soldering on how to solder these motors and in general how to solder. We'll pick up later with another video on soldering switches.